Hi everyone, welcome back to Civil Engineering with Amir. This is the third question from Craig's Mechanics of Materials or Solid Mechanics on the topic of stresses on inclined planes that we are going to solve together. But before we start solving the question, I would like to ask you guys to hit the subscribe button in the right corner and subscribe to our channel if you haven't already. This is a great way to support us. Let's read the question together. Okay, so here we have two wood strips. And we're going to glue these two wood strips together. So we have two options. One is using finger joint splice, and one is using diagonal lap joint. We also have two types of glue. In one of them, the allowable shear stress is half of allowable axial stress, and in the other one, the allowable shear stress is actually 2 times sigma allowable. The allowable tensile load for the finger joint splice is called PF, and for the diagonal lap joint splice is called PD. And now the question wants us to determine the ratio of PF allowable over PD allowable for each of these two glue types. So we're going to start with the finger joint splice. So if this is our PF, this is our shear force, which we call VF. And this is the normal force, NF. This is our y-axis, this is our x-axis. This is t-axis. This is n-axis. And this is going to be 8 degrees. Now, if we write the equation of equilibrium in this direction, we can say sigma Fn in this direction is equal to 0. So Nf minus, so if this is Pf, this is 8 degrees. This is going to be Pf sine of 8 degrees is equal to 0. So Nf is Pf sine of 8. If we call this cross section A, this is 8 degrees. This is A, N, and F. So A divided by A and F is sine of 8 degrees. So A and F is A divided by sine of 8 degrees. Now, for the axial stress in the n direction, we can say sigma NF is equal to this NF divided by A NF, or PF sine of 8 degrees divided by A divided by sine of 8 degrees, or PF over A sine of 8 degrees in a power of 2. Now, if we say sigma allowable is equal to sigma N and F, this is PF allowable divided by A sine of 8 degrees in the power of 2. This will give us a PF allowable equal to sigma allowable A divided by sine of 8 degrees in the power of 2. So this is based on sigma. And now we have to determine a PF allowable based on the shear stress as well. If we write the equation of equilibrium in the t direction, we can say sigma in this direction, F, T, and F is equal to 0. So VF, this is PF. So this is going to be PF cosine of 8 degrees minus PF cosine of 8 degrees is equal to 0. So VF is PF cosine of 8 degrees. And now for the shear stress, we can say tau N T and F is equal to VF divided by A and F, or PF cosine of 8 divided by A over sine of 8 degrees, which will give us PF over A sine of 8 cosine of 8. Now if we say this tau allowable is equal to tau N T and F, or PF allowable over A sine of 8 cosine of 8, we get PF allowable equal to tau allowable over sine of 8 cosine of 8 multiplied by A. And this is based on the shear stress. So these are for the finger joint splice. Now we have to follow the same procedure for the diagonal lap splice. Okay, so for the diagonal splice, this is our VD, this is our ND, this is our PD. So Y direction, X direction, this is T direction, and this is N direction. This is 30 degrees. So if we write the equation of equilibrium in the N direction, we can say sigma F N in this direction is equal to 0. So ND minus, so this is our PD, and this is going to be PD sine of 30 degrees minus PD sine of 30 is equal to 0. So ND is PD sine of 30 degrees. And we know if this is a ND, this is 30 degrees, A and D is A over sine of 30 degrees. So sigma ND will be equal to ND over AND, or PD sine of 30 degrees divided by A over sine of 30 degrees, or PD over A sine of 30 in a power of 2. Now, if we say sigma allowable is equal to sigma ND, this is going to be PD allowable over A sine of 30 degrees in the power of 2. And PD allowable will be equal to sigma allowable A divided by sine of 30 in a power of 2. This is based on sigma allowable. And now if we write the equation of equilibrium in the t direction, sigma f t d in this direction is equal to 0. So Vd this is 30 degrees minus PD cosine of 30 is equal to 0. So Vd is PD cosine of 30 degrees. And tau NTD is equal to Vd over A and D, or PD cosine of 30 degrees divided by A over sine of 30, which is PD over A sine of 30 cosine of 30. Now if we say tau allowable is tau NTD, or PD allowable over A sine of 30 cosine of 30, our PD allowable will be equal to tau allowable A over sine of 30 cosine of 30. So this is based on tau. Okay, so this is the summary of what we have determined already. Now let's start with part A, where tau allowable was half of sigma allowable. So for the finger joint splice, if we calculate the value of sine of 8 in the power of 2, we can write this is equal to 51.6285 sigma allowable A. And here if we calculate the value of sine of 8 cosine of 8, we can say this is equal to 7.2559 tau allowable A. And we know tau allowable is half of sigma allowable. So here we have 3.6 0.62796 sigma allowable A. And now between these two values, we have to pick the smaller value for our PF allowable. So PF allowable will be 3.62796 sigma allowable A. For the diagonal joint, if we calculate the value of sine of 30 in the power of 2, we can say this is equal to 4 sigma allowable A. And here, this is 2.3094 thaw allowable A. And thaw allowable is half of sigma allowable. So this is 1.1547 sigma allowable A. And again, the smaller value between these two values will be our PD allowable. So PD allowable is 1.1547 sigma allowable A. And now, based on these two values, we can calculate the ratio between PF and PD allowable. So PF allowable over PD allowable will be equal to 3.62796 sigma allowable A over 1.1547 sigma allowable A, which is approximately equal to 3.14. So this is for part A of the question, where our thaw allowable was half of sigma allowable. Now in part B of the question, we have thaw allowable is 2 times sigma allowable. The value of PF allowable doesn't change. The value of thaw allowable will be equal to this multiplied by 2, which is 14.5118 sigma allowable A. And again, we have to pick the smaller value for our PF allowable, which is this one. So this is 14.5118. And this one, we have to multiply it by 2, which is 4.6188 sigma allowable A. So between these two values, this one is smaller. This will be 4 sigma allowable A. And now PF allowable divided by PD allowable will be 14.5118 sigma allowable A over 4 sigma allowable A, which is approximately equal to 3.63. So for part B, where thaw allowable is 2 times sigma allowable, the value of PF allowable over PD allowable is 3.63. Okay, that's it. Thanks for watching this video. If you liked it, please press the like button. If you have any feedback, comments, or suggestions, don't forget to write for us in the comment section below. And finally, if you haven't subscribed to the channel yet, please support us by hitting the subscribe button. Thanks again for joining me today. See you in the next videos.